Have you ever really, truly stopped to think about what's going on inside your phone or your computer? I mean, it feels like magic, but it's not. It's something, well, something even cooler. Today, we're going to trace the path from a literal handful of sand all the way to the artificial intelligence that is changing our world. Let's dive in.
Wow. This quote, it just cuts right to the chase, doesn't it? It's a pretty shocking thought, but honestly, it perfectly sets the stage for what we're about to unpack. I mean, how on earth did we get here? How did we give a mind to something you find on a beach?
To really get a grip on this revolution, we have to go back, way back, all the way to the absolute most basic, fundamental building block of this entire story.
Yeah, you heard that right. The very foundation of our entire digital world is basically purified sand. It's kind of a mind-blowing thought, isn't it? That the most sophisticated technology humanity has ever dreamed up comes from something so common, so humble.
Okay, so here's the first huge leap. We take that purified silicon and we manage to craft these things called transistors. The best way to think of a transistor is as the atom of the digital world. It's just a microscopic switch. It can only be in two states, on or off, a 1 or 0. That's it.
The idea itself is so simple, right? It's just a light switch. But the real magic here is the scale. We're not talking about one switch. We are talking about billions, with a B of them, all crammed into a space smaller than your fingernail. It's this absolutely bonkers density that gives computers all their power.
All right, so we've got billions of tiny light switches. So what? How do you get from a simple on or off to something that can actually, think? Well, it all starts when you combine them. This is where the first spark of intelligence appears. We wire a few of those transistor switches together to create what we call a logic gate. And suddenly, it's not just on or off anymore. It's a teeny tiny decision maker. It takes in some signals, and based on a very simple rule, it gives you an answer.
This is the perfect example of how it works. Think of it like a bouncer at a nightclub. The rule is simple. If you have an ID and you are over 21, then you can come in. The logic gate takes those two inputs and gives one simple output, yes or no, 1 or 0. This is the very foundation of all computer logic.
Now just imagine stringing millions of these tiny decision makers together. All of a sudden, you can do incredibly complex things. You can calculate huge numbers, you can run a video game, you can browse the internet. For the longest time, this was all programming was. Humans writing super specific, logical rules for the machine to follow, one tiny, tiny step at a time. But right here, this is where our story takes a massive, dramatic turn. See, following rules is one thing, but what happens when we stop giving the machine the rules? What if, instead, we teach it how to learn them all by itself? And this is the fundamental shift, the real game changer. On the left, you've got the old way. People painstakingly writing out every single instruction. But on the right, you have machine learning. We stop telling it how to find a cat in a photo. Instead, we just show it millions of photos of cats and basically say, you figure it out. So the crucial thing to get here is that instead of code, the key ingredient becomes data. Piles and piles of it. We use one pile, the training data, to let the machine build its own understanding. And then we use another pile, the test data, to see how well it actually learned. The whole goal is for the machine to find patterns that we might never even see ourselves. And the most powerful engine for this new kind of learning is the neural network. The idea is brilliant. Let's try to create a digital version of a brain. A huge web of interconnected digital neurons that can weigh information, pass signals to each other, and literally adjust their connections as they learn from data, getting stronger and smarter over time. So we've come all the way from sand to switches to learning machines. But this incredible leap has created a profound and, frankly, kind of spooky mystery. We've built a mind, but do we actually understand it? This is it. This is the question that keeps researchers up at night. The machine gives us the right answer. It identifies the cat, it translates the sentence perfectly, it writes a beautiful poem. But what was its thought process? What's the actual logic going on behind the scenes? And this gets us to the very heart of the black box problem. It's like having a brilliant mathematician who aces every single test but never ever shows their work.
You get the correct answer every time, but the journey to get there is totally hidden inside this impossibly complex web of connections that the machine built all by itself. You know what's really wild? Even the people who design these neural networks can't fully map out the logic. They create the basic architecture and the rules for learning, this error function, but from there, the AI forms trillions of connections completely on its own. The internal reasoning becomes this emergent property of the system. It's almost alien to us. And so, this brings us to our final and most critical question. We started with sand, and we ended up with a black box. We've given it the ability to learn, but not the ability to explain. So as these systems start making more and more critical decisions in our world, in medicine, in finance, everywhere, we really have to ask ourselves, how much faith can we put in a mind that we don't truly understand?